So this question reads, the total current passing through the circuit is 0.4 amps as shown by the ammeter in the figure below. The total current passing through the circuit is 0.4 amps as shown by the ammeter in the figure below. So this is the current that is passing through the whole circuit. Now the questions read, carefully study the circuit above and calculate the value of X. So this is the same question as before, right? They want us to find the value of X. This is a resistor. We have how many resistors? We have 1, 2, 3, 4, and 5. So we have 5 resistors here. They want us to find the value of X here. Whilst they've given us the figures for all these guys. This is what we've been given. So how are we going to find the value of X? This is where the question is. How are we going to find the value of X? We are going to use what we call Ohm's law. We'll use what we call Ohm's law. Now, what does Ohm's law state? It says to say the voltage in a particular circuit is equal to the current multiplied by the total resistance, right? We already have the total voltage and we also have the current like that, which means what are we supposed to do? We are now going to find the total resistance. We are going to rearrange this equation by dividing both sides by current I, even that side by I, so it will cancel out the current there. That means our total resistance will be equal to voltage divided by current. Are we together? So what is the voltage? The voltage is 6 volts. The current is 0.4. 6 divided by 0.4?
15.
15 ohms. That means the total resistance in this whole circuit is 15 ohms. Now that we've gotten the total resistance in the whole circuit, what are we going to do? We'll go back to our question and look at the arrangement of our resistors. Remember what we are talking about in the previous question? We said when resistors are in a parallel arrangement like this, the reciprocal of the total resistance will be equal to the reciprocal of the sum of these individual resistance, the individual values of resistance that we have here. So you can notice to say the 2 ohm resistor is in a series connection with this parallel combination, which is in series with X. So what are we supposed to do first? We're supposed to find the total resistance on the parallel combination, because we know once we find the total resistance here, we're just going to say 2. Our total resistance will be equal to 2 plus the combination there plus X being equal to 15. You get what we're doing, right? We're from doing the same thing in the previous question. So first things first, let's find the total resistance on our parallel combination. So we'll say 1 over R total will be equal to 1 over 12 plus 1 over 6 plus 1 over 3. Kindly add these 3 values for me. 1 over 12 plus 1 over 6 plus 1 over 3. What do we get? What do we get? 1 over 12 plus 1 over 6 plus 1 over 3. What is the answer?
0.58.
0.58, that's the answer? Meaning I should say 1 over R total is equal to 0.58. This is what you mean, right?
Yes.
Okay, so let's divide both sides by 1, cross multiply. We're going to get 0.58 R total being equal to 1, like that. So let's divide both sides by 0.58, even that side by 0.58. This will cancel out. That means our total resistance will be equal to what? 1 divided by 0.58.
1.72.
1.72, not 1.71. Are we getting the same answer? Are we getting the same answer?
Yes.
Okay, so 1.72 ohms, like that. Okay, so if this is the total resistance here, 1.72 ohms, that means we can now find the value of X, because these three are now in a series combination with each other, or in a series connection with each other. We have the 2 ohms resistor, which is in series with the 1.72 ohms resistor, which is in series with the X, like that. So I'll say my total resistance, our total, will be equal to 2 ohms plus 1.72 ohms plus X plus X. Maybe I should write the X like that. Okay, so the total resistance we've already calculated here to say it's 15. So 15 will be equal to 2 plus, okay, so this is going to give us 3.72 plus X, like that. So 15 minus 3.72, this will be equal to X. So what is the value of X?
Hmm? To my nose.
What is the value of X from here?
11.28.
11.28 ohms. That is the value of X. Resistor X has a magnitude of 11.28 ohms. As simple as that. Is there anyone with a question from part one?
So weird.
Is there anyone with a question from part one? All right. If there's no question from part one, let's now go to part two. And part two is saying, what is the current passing through the 3 ohms resistor? What is the current passing through the 3 ohms resistor? Okay, so how do we calculate current passing through a resistor now? And here I just wanted to emphasize something before we go any further when it comes to these series and parallel combinations. We need to understand something when it comes to these guys. One of the things that we're supposed to understand is that when it comes to voltage in a series combination here, in a series combination, let's say I have uh, this resistor connected to this resistor, connected to that resistor, like that. Let's say this is R1, this is R2, this is R3, like that. Then I also have a combination in a parallel combination. Let me just do this. So I have a resistor there, also have a resistor there, and another resistor there. Let's say this is R1, this is R2, and this is R3, like that. What you're going to notice is that when it comes to voltage, the voltage in a series circuit here, the total voltage that is entering, or let me just say the voltage that is entering, will be equal to the voltage that is passing through there plus the voltage that is passing through there plus the voltage that is passing through there. So the voltage in the circuit will be equal to the voltage passing through that resistor plus the voltage that is passing through that resistor plus the voltage that is passing through that particular resistor. Whilst when it comes to current in this particular circuit, you're going to notice to say current is going to be distributed equally, which means the current on resistor number 1 will be equal to the current that will be on resistor number 2. And this is also going to be equal to the current that is on resistor number 3. So current is similar across the resistors that are connected in series with each other. Whilst voltage, in order for you to find the total voltage, you have to find the sum of the individual resistors. or the individual voltages that are passing through each resistor that is connected in series with each other, like that. Whilst when it comes to a parallel combination like that, the opposite is the case. The voltage will be similar across everything. The voltage that enters the cell is shared equally across all the three resistors. That means the voltage here will be equal to the voltage that we have there. And that will also be equal to the voltage that we have there. Also, when it comes to the current, the total current in the circuit, the current that is entering the circuit will be equal to the current that we have there. Oh, this is 1 plus the current that we have there plus the current that we have there. So why am I explaining this to you? It's because I want us to look at this combination that we have here. They've told us to say what is the current passing through the 3 ohm resistor. Where is the 3 ohm resistor? The 3 ohm resistor is here. The 3 ohm resistor is in a parallel combination with these two. And we said these three are in a series combination with what? With those guys. So what are we going to do? Let's first find the current that is passing through this resistor and the current that is passing through this resistor. Then, using these two, we'll be able to find the remaining current. Or rather the voltage. We can use voltage, I think. Since they've already given us to say the total is 6 volts, we can find the voltage that is passing through that resistor, the voltage that is passing through that resistor, then the remaining voltage will be shared equally amongst those three. Yes, I think we should use voltage. The remaining voltage will be shared equally amongst that three because we said voltage is the one that is shared equally when it comes to the parallel combination of resistors. Then once we find the voltage, we'll be able to use the equation for calculating current, the Ohm's law, in order for us to be able to get the current that is passing through the 3 ohms resistor. Have you understood what I'm saying?
Mm,
Have we understood what I'm trying to say?
Yes.
Okay, so we said using Ohm's law, voltage is equal to what? It's equal to total current multiplied by what? Multiplied by the resistance, right? This is how we calculate the voltage passing through a particular resistor using Ohm's law. Now let's calculate the voltage that is passing through the 2 ohms resistor. What are we going to do? We're going to say voltage will be equal to the total current since these three are connected in series. This is connected in series to that, which is connected in series with that. That means the current here, what I've written here, the current is similar in all three of these. This is what I'm from explaining. So what are we going to say? We're going to say the current, which is 0.4, multiplied by the resistance, which is 2 ohms here. So that means the voltage passing through the 2 ohm resistor will be equal to what? What is the value of the voltage there?
0.
Sorry?
0.8.
Okay, 0.8. 0.8 volts, like that.
Yes.
Okay, what about the voltage passing through this X resistor, which we found to be 11 point. So we're going to say voltage will be equal to 0.4 multiplied by 11.28. What will be the voltage there?
4.512.
Sorry.
4.512.
4.512. This is what we are getting. Why does this number look so big? Okay, so if we add this and that, what are we getting?
I'm getting this one. I'm getting 11.68.
0.4 multiplied by 11.28, you're getting 11.68.
Apologies, I was adding instead of multiplying.
Oh, sorry. Yes, so what do we do? Oh, I mean, what is the value of 0.4 multiplied by 8?
It's 4.512.
Okay, if you add 4.512 and 0.8, what are we getting?
5.312.
5.312. 5.312 volts. That is it for that one and that one. Now let's say the 6 volts, which is the total, minus the one that we've calculated here. So say 6 volts minus 5.312 volts, like that. What voltage do we remain with? What voltage do we remain with?
0.688.
Okay, zero. Oh, it's zero. 0.688 volts. 0.688, right?
Yes.
Okay, so now we know that this 0.688 volts is the one that is passing through what? Is the one that is going through this parallel combination that we have here. And you know to say when the combination is parallel, voltage is similar in all the three resistors, which means there is 0.688 there, there is 0.688 there, there's also 0.688 there. So that means now we can apply Coulomb's law or Ohm's law here so that we find the resistance of the 3 ohm resistor. Find the answer and tell me what the answer is. They want us to find the current that is passing through the 3 ohms resistor. So we have the voltage on the 3 ohms resistor. It is 0.688 volts. We have the resistance of the 3 ohms resistor. It's 3 ohms itself. Now, what are we going to do in order for us to find the current? We're going to use the same Coulomb's law. Say voltage is equal to current multiplied by resistance, like that. The current will be equal to what? It's the one we are looking for. So divide both sides by R, even that side by R. So our current in the 3 ohm resistor will be equal to the voltage on the 3 ohm resistor, which is 0.688, divided by the resistance of the 3 ohm resistor, which is 3 itself. So what will be the current?
Uh, 0.229.
0.229 amps. That is the current on the 3 ohm resistor.